This assembly stage shows you how to build original equipment bass traps. Suffice to say, in this video, I will be commissioning, the initial prototype or the conceptualized idea into an OE build. Firstly, I will be validating and reviewing the design, okay? The bass trap that will be constructed will be sat from the floor up to the ceiling and will extend from both right-angled side and corner walls. This will enable the working out of how many pine woods we need, as well as how many hardwood plywood I will need, okay? The pine wood will form the pillar structure, whereas the hardwood plywood will form the top and the bottom base of the bass trap. So here I will be using a circular saw to split a 4 feet by 2 feet hardwood plywood into 8 sections. And that is because a build of 4 bass traps requires 8 diagonally cut hardwood plywood, as you can see here. Y is the hypotenuse, which is about 2.828 feet. And if you split that into 2, you get the width or depth spread, which is X, and that equals to 1.414 feet, okay? And so basically, we've worked out that the 4 feet by 2 feet hardwood plywood and board will give us 8 bass straps. We're not going to have any waste. And we've identified that the length of spread of the bass trap is about 2 feet. And the width or depth of spread of the bass trap is about 1.414 feet. This will enable us to establish our bill of materials and ensure that, parts are not surplus to requirements, okay? It's important to work out your bill of materials to prevent waste and to prevent line stops due to shortage of materials, okay? The hardwood plywood's length is about 1220 millimeter, its breadth 610 millimeter, and its thickness or depth 9 millimeter, which equates to about 4 feet by 2 feet with respect to its length and breadth, and 0.02 feet with respect to its depth. So the next step of the process would be to line up the cutting mat diagonally, across the hardwood plywood and trace out the cutting line. Then subsequently, flip the cutting mat around and trace out the other cutting line that's opposite, the one that was previously drawn, until we get 4 sections, okay? The next step of the process would be to map out the entire, assembly test process so that we can see at first glance, or skimming through, if we've got any parts shortages, or if there is any non-conformance at an early stage, to save on time, quality and cost, and to ensure a first time pass yield, that the fabrication or the build of the bass trap passes the first time, as opposed to making reworks and alterations to achieve our goal, okay? So here I have modeled, the pine wood onto the hardwood plywood, and we've got pine woods, of varying lengths, the long and short, to provide reinforcements for the bass trap housing structure. And if we glide through the model's panoramic view, you can see how the bass trap would look like on the outside and on the inside as well, okay? And here I've reinforced this angled bit that would sit into the wall, okay, with 2 pine woods, which will be assembled at right angles so that the bass trap housing fits perfectly into the right angled walls, which is the position where it will seat in. The erection of the housing structure, as shown in the model, will be replicated for other bass trap hardwood plywood sections. So I will erect more pine wood on other hardwood plywood sections. 3 of the bass traps will have the same height, whilst 1 of the bass trap would have a slightly longer height, and when compared with the other 3 bass trap, and that's because I will want it to, to cover the full spectrum height up from the floor to the ceiling. And if you visually inspect or measure the pine wood, it's got a thickness of 1 inch or 1.4 inches, depending on which of the pine wood housing structure you're looking at. Which invariably means that if you use a thicker screw or a screw with a larger diameter, it could result to splitting of the pine wood. So we're going to be looking for a thin screw, and I've selected the 60mm in length and 4mm in diameter screws, which equates to about 2.375 inches in length screw. This 4mm in diameter and 60mm length screw is quite fit for purpose, as it's got a short tooth that prevents splitting. It's quite thin. It will go through the pine wood without splitting the pine wood. If you use a larger screw, that could split the pine wood. And pilot drill if you must before opening up the hole to your 4mm diameter. Okay, but you can see we've got different lengths here. One of the pine wood is longer than the other pine wood in terms of the height. And that's because on final assembly, when we stack each bass trap on top of each other, we want all of the bass traps to catch up to the ceiling, to accumulate up to the ceiling. Okay, pretty much compound to meet or achieve the ceiling height. And like I said previously, we're going to attach or fit the diagonally cut hardwood plywood, onto the top of the housing and pine wood structure, as well as the base. So the process would be, cut the hardwood plywood into sections using a circular saw, and then subsequently pilot drill the pine wood with the drill bit, then, open up the hole and then screw the diagonally cut sections onto the top and base of the housing structure of the base trap. Here we've got like a 4mm in diameter screw, which is 60mm in length and has got like a short tooth to prevent splitting, which is illustrated in the diagram as shown. And so, as earlier highlighted, if the thickness or depth of your pine wood structure or housing is quite thin, then by all means get a thinner screw, so that when you screw it in through the piloted holes or the opened up final hole sizes, it doesn't result to splitting of the pine wood. Okay. And if you visually inspect the screw, you can see that the top side of the screw hasn't got thread, on its upper side, which means that when you're opening up the piloted holes to its final size, make sure that you drill right through. Otherwise, you wouldn't be able to get, the screw in when you're screwing it down. Okay, so just make sure that you carry out due diligence. You know exactly what you're doing, and so that you're not damaging your wood. Okay. And on visual inspection, just as shown on the diagram, it's got the short tooth that prevents splitting. And if I lay the screw side by side on the scale, you can actually see that it's 60mm in length. So you can also confirm it that way if you haven't got like a meter rule, okay, or a measuring tape. And lastly, the screws caveat says, when torque tightening the screw, you utilize a PZ2 screw bit, okay? The next step of the process would be to diagonally cut the hardwood plywood into sections using a circular saw. First, you clamp the hardwood plywood, onto your workbench, or in this case, an improvised rack. And then subsequently, attach your dust extraction adapter to your circular saw, and then your vacuum hose, attach that to your flexi waste straight coupling, okay, which will help in channeling a lot of the foreign object debris into your vacuum, okay. And like I said initially, clamp the hardwood plywood board into position prior to using the circular saw. And once the hose coupling and the dust extraction have been securely attached to the circular saw, then you can cut, the hardwood plywood diagonally, through the cutting line. click on the link in the description, if you want something more incisive on how to use the circular sawer and how to set it up and how to cut, your hardwood plywood diagonally, or sectionally, okay? How to select your blades, how to get quality cuts and whatnot, okay? If you want something more incisive, click on the link in the description. And so, as highlighted in the description link, I have deployed the use of a rack to make diagonal cuts. You don't have to do this. You can deploy the use of a table saw, and that's because I know exactly what I'm doing. There is no movement. It's kind of like freehand cutting, through the cutting lines on the hardwood plywood board. But if you haven't got a table saw and your workbench, it's an impediment to making diagonal cuts, then you might as well give this a go, but just make sure that your G-clamps are adequately secure. Where they secure or latch onto the hardwood plywood board, make sure you're not impressing your weight, on the table saw and the hardwood plywood, and also make sure that your rack, there isn't any movement, with regards to your rack when you're using the circular saw, to make diagonal cuts through the cutting lines, or when your blade starts to get traction, on the plywood hardwood board. So make sure that there isn't any movement, prior to cutting through the hardwood plywood, okay? And also for quality cuts, make sure that you select quality blades. We haven't used the appropriate blade in this instance, and click on the link in the description to see why this isn't the appropriate blade. The blade just about does a good job with respect to getting fine quality cuts around the edges of the hardwood plywood. And why it's important to have that, and that's because you'd be having your acoustic fabric around the perimeter of the top and bottom hardwood plywood and baseboards, okay? So here we've replicated the process. We've got 8 hardwood plywood diagonal section boards that have been cut, and we've got the long and short pine woods that would be used to fabricate or to assemble the structure of the base traps. So carry out due diligence, make sure you measure the height from your floor to the ceiling, and just kind of work out the height of the base straps that you will be fabricating, or you will be cutting to size, okay? You might want to use a combination blade or a special purpose blade to cut hardwood plywood and boards, as the veneer sheets that are laid on top of each other. If you've got rough edges, by all means, sandpaper to smoothen it out, with a coarse sandpaper or with a fine sandpaper wherever applicable. And if you're not willing to go ahead with the concession, you could, draw another cutting line, don't take too much off the edges, and, use your circular blade, to cut off, the edges where appropriate, okay? But just make sure that, for each base trap that, the dimensions of the measurements, they tally with each other. So at this stage, it's imperative that you validate the dimensions of the pine wood. Make sure that, the base traps that are the same height have got exactly the same dimensions in their structures. Suffice to say, make sure that the pine woods are cut to size with respect to their dimensions. Here, I have decided to have 3 base traps of the same height and 1 outstanding base trap of a different height. So I will be mapping them out so that I make sure that certain parts go where they are required and that I do not mismatch the parts, okay? I don't want to mix them up, so I'll map it out, then begin to assemble each component gradually from their respective positions in situ. And also use this opportunity to make sure that all the accessories, all the components that will be used in assembling the base traps are within the work area, okay, but they're not causing any obstructions, any slip and trips, okay, so that all the base traps are fabricated just in time and there isn't any line stop with regards to how readily available the base traps are manufactured or assembled. And now that we've validated and accounted for all the parts in the bill of materials, we can actually proceed to build the base traps from lower level to top level, where we finally put on the acoustic fabric. And if we have any buffer stock or any extra pine wood components, that we can reinforce, the unidentical BassTrap with it, okay? So just bear that in mind, that the housing structure isn't set in stone. You know, at the very bare minimum, you know, this is what we have, but we can always reinforce, you know, the structure where necessary. Prior to pilot drilling, ensure that the drill bit's profile is slightly smaller than the diameter of the screw, which is 4 mm. And here you can see that the thread of the screw protrudes slightly more outwards than the drill bit. That ensures a tight fit, okay, when we torque tighten the screw downwards. So the first step of the process would be to pilot drill, you know, holes between, you know, pine woods. Vary the drill speed to 2 for drilling, and ensure that, you know, whilst you're drilling, you know, through the pine wood, that you drill all the way through when you're pilot drilling. And that's because the top part of the screw hasn't got any thread. That would enable you to torque tighten the 4 mm diameter screw more easily at a later stage. Ensure that you've got like a scrap material, you know, underneath the pine wood so that it doesn't damage your flooring, okay? That is if you're not using your workbench to pilot drill your pine wood, okay? So what I will be doing here essentially is to pilot drill, you know, the pine wood frame structure or the pillars, okay? Then subsequently torque tighten, you know, the 4 mm screw through, you know, the perforated holes in the pine woods, you know, just to give it some traction, you know, when we're screwing both or assembling both pine wood frame structures together. I'll show you what I mean here. Otherwise, if you just, you know, pilot drill and you're trying to screw the screw directly from one pine wood to the other, you may have difficulty, you know, in torque tightening the screw all the way down. So when you pilot drill your pine wood, you know, individually or discreetly, or, you know, screw down the screw on standalone pine woods before you attempt to assemble, you know, both pine woods together. And also you can also infuse some Gorilla Glue in between both pine woods to provide a more steadier and built frame, essentially to provide the solid rigid connection that we're looking for the housing pillar structure. In this process step, if you're assembling two pine woods with, you know, a larger width, you might as well use a long screw, you know, like the 4 mm screw. But if you're assembling the diagonal cut hardwood plywood onto the pine wood, you need a smaller screw, okay? And that's because the hardwood plywood's thickness or depth isn't as thick as that of the two pine woods being assembled together. I'll show you what I mean at a later stage, but at this stage we're going to be using the thin 4 mm diameter and 60 mm long thin screw, you know, to assemble pine woods together. You can see here that I'm screwing, you know, the screw through the pine wood and it's not splintered, okay? And you can see that I am assembling, you know, the pine wood onto the other pine wood frame. And because I had initially run, you know, the screw through both pine woods, it's a lot easier to torque tighten both pine woods together. And why I'm having to do this is to avoid any splintering, to enable good traction when torque tightening the screw through both pine woods, so that I do not compromise on time, quality and cost. This process will be replicated throughout the entire assembly process of the pine wood housing pillar structure. And you can see what we discussed earlier. So I've driven the screw previously to the bottom pine wood, okay, taking the screw out, and I'm, you know, assembling, you know, the top part of the pine wood structure onto the lower level pine wood that sat on the workbench or clamped to the workbench. This makes it easier to torque tighten the screw through the piloted hole, as the top part of the screw hasn't got any threading on it. The next step of the process would be to assemble the diagonally cut sectioned hardwood plywood onto the already assembled pine wood housing pillar structure. Here you don't need to torque tighten with the 60 mm length screw, and that's because the plywood hardwood depth is about 9 mm, so 60 mm is way too deep in, okay, but you can get away with it. But, you know, to avoid splintering, by all means use a shorter screw. And you would see in other base traps that I've replicated the process with a mismatch of screws. So I haven't just used long screws, okay? I've also used shorter screws, and because I do not require a 60mm depth to secure the hardwood plywood base onto the pine wood structures. So at this stage, I am replicating the entire assembly of the housing structure and base structure. Just to jog your memory, sort of like a recap. Well, I wouldn't be going into, showing all of the assembly of all of the base traps, because that would just, take time. But you do get the hang of it, don't you? But I will be showing you a 2D or somewhat panoramic view of, the assembled housing frame structure and base structure, okay? So here, I have replicated the process and assembled all the housing frame structures to them plywood bases, and here you can see the unidentical base trap. It's got a different height and only 3 pillars supporting the housing frame, which is subject to reinforcements, whilst the other 3 housings are identical, with a number of pillars supporting, both the top and bottom and plywood structures. So here, I will be visually inspecting the top level assembled housing structure with their respective bases to make sure they are as per the design review, okay? And so far, there's been no bottlenecks, concessions, or non-conformance. To see how to overcome the rework of the diagonally cut, plywood bases with respect to kickbacks or binding when using the circular saw, click on the link in the description to get something more incisive with respect to how to use circular saws to cut hardwood plywood. And you can see, just by visually inspecting the screw heads that have been used to tuck tighten the hardwood plywood sectionally or diagonally cut boards onto the housing frame, that they have different colors, and that's because some screws are shorter than the 4mm in diameter and 60mm in length screw that was used initially to couple pine wood together. And like I said, the plywood is only about 9mm thick, so I definitely needed shorter screws to couple it onto the pine wood structure, and so I used shorter screws, okay? Just saves the pine wood from splintering and driving the screws further in when you don't need to. And here you can see where I've reinforced the unidentical base trap with more pine wood, on the sides. This would make it more sturdier, okay? Helps with anti-tipping with respect to the slightly more increased weight, and also helps, the acoustic fabric latch onto the housing frame structure, flush wise, as you would want to minimize or prevent the RockWool or acoustic material from protruding through the acoustic fabric when you latch the acoustic dampening fabric flush over the housing frame and the diagonally cut plywood hardwood board bases. And as you can see here, the reinforced sidewood frame would give the acoustic fabric a more uniform flush look as opposed to an uneven look, okay? And if you can, where necessary, by all means install the side wood pine wood frames, as it will not just help with the aesthetic look of the acoustic fabric, but it will also help keep the RockWool in check or in place so that it doesn't just fall off relatively easily from the top or bottom, okay? If your diagonally cut base plywood boards have got rough edges, you could sandpaper the edges of the triangular hardwood plywood board with coarse or fine sandpaper, depending on the degree of fineness or smoothness that you're trying to achieve. And if you also zoom out on the hardwood plywood board, you will notice that certain edges are receding on the inside, and that's because the hardwood plywood sectionally cut diagonal boards were freehand cuts with the use of a circular saw. Pretty much just cut through a cutting line, so there will be a marginal degree of human error when fabricating or cutting the hardwood plywood base boards. The pinewood side panel reinforcement helps to accommodate this deviation by providing a seamless uniform look when the acoustic dampening fabric latches on to the BassTrap assembly. The next stage of the assembly process is to insert and stack RockWool wedges on top of each other from the floor of the bottom base hardwood plywood to the ceiling of the top base hardwood plywood, whilst ensuring that it is compact all through its clearance height. This would help prevent movement or play when we cover the housing structure with the acoustic dampening fabric. One of the advantages of using RockWool is that it's quite versatile. You can cut it to any shape or size that you want, okay? In this case, I've made triangular shapes, okay, to fit right into the base traps. And as you can see, with the aid of a Stanley knife, I can cut out a triangular pristine shape, okay? This is just for demonstration purposes, okay? And so this process has been replicated for all of the other base straps. And if I get you a panoramic view or 2D view of the filled in or stacked base traps with RockWool, you can see that it's quite compact. It's all been stacked in all of the housing structure frames, and there is little play of movement in them housing frame structures. Also make sure that the RockWool isn't protruding from any of the three sides of the housing frame structure so that they don't bulge from the acoustic fabric, which will be fitted on at a later stage. Here I will be using acoustic pads and the remnants of towels, advanced acoustic BassTrap corner fills and RockWool fills, okay? The advanced acoustic BassTrap corner fill remnants are embedded in the grey towel and sealed off with industrial or fabric glue, whilst the RockWool remnants are embedded in the white towel pieces and sealed off with a fabric transparent glue, okay? So you don't always have to discard leftover pieces, you can always put them to good use, okay? And lastly, I've got acoustic pads that have been flipped over on each other and stacked in the BassTrap frame structure. As standalones, these acoustic pads may help slightly with reflections, with mid-range and high frequencies, but not particularly low frequencies, okay? But when stacked on top of each other with towels, acoustic BassTrap remnants and RockWool, they might, be quite effective with regards to reflections or low frequencies in a BassTrap. If you have to use a combination of acoustic material to make sure they are compact, you stack them on top of each other and you use the remnants of the acoustic dampening fabric to provide leverage so that it doesn't bulge out from your final covering, okay? If you don't have access to RockWool, you could do this. My first preference would be RockWool, but if you haven't, you could use the remnants. They also do a cost-effective job, okay? Or just stack wedges on top of each other, and that could do the job as well. The more you get them into your room, the more it helps with soundproofing. The final step of the assembly stage process would be to cover both the identical and unidentical base strap with the acoustic dampening fabric. Base straps do not just absorb the low-end frequencies in your studio or room, they also help to absorb or better define the low frequency, making them easier to control and recognize, which in turn helps you achieve better results in your recordings. The first step of the sealing off process would be to cut the acoustic dampening fabric in squares or rectangles. Suffice to say, first cut the fabric length with respect to the perimeter of the housing frame, and then subsequently cut the fabric breadth with respect to the height of the housing frame. This will ensure that the cut fabric secures or seals off the entire housing pillar structure. You could deploy the use of a permanent marker and a cutting mat so that your cutting line is quite visible on the fabric, but make sure that you're marking the fabric on the underside or the back of the dampening fabric. And as you can see, I'm running the scissors through the cutting line, and it's a quite cost-effective way of saving on material. And how do you deduce, the perimeter? Just get your measuring tape. It's quite flexible around the 3 pillar supports, on the housing frame, and you should be able to work out, what length and what the height of the clothing you need to cut. So work out, how you're going to wrap around your bass trap housing frame and bases before you start cutting, to save on material, because it can be quite costly, them aesthetically quality, good looking ones. The fabric is stretchy, so don't overly stretch them when you're sealing off the housing frame to avoid incidences of slack over time, but they rarely ever do that unless you overly stretch on them. Okay, but it's not something to worry about. And for both the top and bottom bases, measure the length and breadth of the diagonally cut hardwood plywood. So cut a square from your fabric cloth as opposed to a triangle, okay, so that it covers, the entire perimeter of the top and bottom base, using the length and breadth measurements from the originally obtained measurements from the diagonally cut hardwood plywood baseboards. So I have pretty much replicated the process for all 4 base traps, ensuring that the dampening fabric, covers the baseboards and the structure housing frames. And so now that we've wrapped around all of the base traps, the next step of the process would be to window dress all base traps, and then subsequently deploy the use of a stapled gun to seal off, the dampening fabric onto the housing frame and base structures. So now that we have worked out the amount of material that will cover the base structures as well as the pillar structures, I'll start off by sealing off with a stapled gun, both top and bottom bases. Then engulf the material that has been stapled onto the top and bottom bases with the dampening fabric that covers the housing structure pillars. Okay, then I'd staple that onto the top and bottom bases. So we've got, if you've got any pins that do not sit flush on the base structure, get it off by all means with a staple remover, and then continue to proceed with your stapling whilst ensuring no loose ends. And once you're done, stapling, ensure that all pins are flush with the aid of a hammer. Just give it a good definitive bang with reasonable force. The process in the aforementioned will be repeated or replicated for other base traps until all of the housing frame and base structures are sealed off. And as previously highlighted, if you want to avoid receding lines, then, invest more in the quality of the blade that you'd be using on your circular saw, okay? This topic has been well broached in the video in the link in the description, so by all means click if you're interested in finding out what type of blade you'd need to procure. And as discussed in other videos, the quality of blade and the type of material you're cutting is crucial with respect to getting fine, clean, quality cuts, on the hardwood plywood boards. Make sure that you give the dampening fabric a good, nice, clean cut fold at the corners to make it more aesthetically pleasing. And as previously highlighted, just replicate the process for other base traps. Acoustic panel fabrication or build are much suited to absorbing mid and high range frequencies, which you can find in the link in the description. Whereas the bass traps being built here are much suited for low frequencies. When comparing sound absorption and soundproofing, we are looking at how different materials interact with sound wave energy. Some materials will absorb sound energy, some will reflect it, and others will allow it to pass through or transmit it. Most materials do a little bit of all 3 depending on the sound frequency. It may work better on mid to high frequency or on low frequencies. Sound absorbing fabric is not soundproof, as it will improve the quality of sound within a room by decreasing reverberation and echo of the sound generated in the room, and marginally decrease transmission of some frequencies between rooms. These sound absorbing fabrics can be used in homes, theatres, recording studios, restaurants, and even churches. Acoustic fabrics are used for draping rooms and absorbing noise, or for wrapping absorbent materials and allowing the sound through. Cloth of different weaves and densities interact with sound distinctly, so select a fabric for the purpose you want. Whether you're looking at getting a sound absorbing fabric or an acoustically transparent fabric. Just take cognizance that the sound absorbing fabric ones will absorb sound frequency waves because they are thick and porous. Suffice to say, the waves enter into the fabric and become trapped in them fibers and folds and convert from sound energy into heat. Whilst them acoustically transparent fabrics are used to cover acoustic panels, bass traps and diffusers that are made of absorbent insulation. They cover and contain the fibers of the insulation while permitting sound waves to pass through as if they weren't there. Many fabrics are transparent or made up of breathable clothing or fabric. And if you're looking, to get a transparent material that, is cost effective, you could use your bed sheets if you're working on a budget. To check if your fabric is transparent, hold it up to your mouth and blow through it. If the air passes easily through it, then it is transparent. There are different qualities of transparent or breathable materials. Look for the cloth of fabric that is strong, durable, dust and strain resistant, and bespoke to the color or pattern that you want. And even if it's fire rated, the better. And here, the final stage assembly of all 4 bass traps has been completed. We've got the grey acoustic dampening fabric on, 1 bass trap, and the remainder of them 3 have got the black acoustic dampening fabric. And the next step of the process would be to check out if the hypothesis in the design review holds out. When we stack up all them 4 bass trap from the floor up to the ceiling. The bass trap has got 2 sides essentially, one which is the forward facing side facing us and a right angled side that will be sat entrenched in the right angled wall profile. So hopefully it should, stack up well against, the right angled wall profile, and it shouldn't wobble, as the base area profile is well spread out with respect to measurements. And as you can see, it just about stacks out right from the floor up to the ceiling. And there isn't any right number with respect to the amount of bass traps that you use, but the more the better, which will significantly help with respect to low frequencies. So basically, throw in as many wedges as you can in them corners of your room to battle them low frequencies, as well as deploy the use of a diffuser. And to battle them mid frequencies and them high frequencies, you could use acoustic panels. And like I said previously, click on the link in the description to see how to build acoustic panels and cost-effective ways to set up your diffuser. If you want to improve the sound in your room, absorption is the way to go. And if you're going to prevent sound from entering or leaving your room, then soundproofing is the way to go. Click on the link in the description for how to build quality acoustic panels and the complete guide for how to build quality bass traps. And that's about it really. If you found the information useful, don't forget to subscribe, like and share, helps the channel grow, and hopefully catch up with you later.